going to start with my presentation because we don't have many time. Let's share my screen.
We see your presentation.
Now,
we see it
right?
Very well.
Yeah, it's fine.
Okay, I'm going to start. So good morning, everyone. I am Paula Delgado, and I'm going to explain my ESR position, that it is ESR number 2, mobile device background sensors, authentication versus privacy. I am located in University of Kent, and my supervisor is Professor Richard Guest, like he said before. So in the first point, I'm going to talk a little bit about my education. I have a bachelor's degree in telecommunication engineer from the Universidad Autónoma de Madrid. Later, I attended a master's degree in telecommunication engineer in the same university. Now I'm going to explain a little bit about my experience. At the same time that I was studying my master's, I was working in a scholarship of IBM together with my home university. The previous year, I was working at a Swiss university, HSVD, as a data scientist, where I was studying loss of learning from imaginary data extracted by generative adversarial networks. Along with this, I was working in my master's thesis in the VIDA lab on signature biometrics. My topic was synthetic generation of time sequences through deep neural networks, which I will finish with honors. So now I'm going to explain a little bit about my ESR position. The specific project will study the data richness of background sensors data elements obtaining from mobile devices, such as accelerometer, gyroscope, GPS, etc. We shall explore how personalized data elements are, thereby providing an analysis as to which elements can enable accurate authentication and which require more privacy protection. In particular, we shall examine the sensitivity of combination of data elements, the ability to infer one data element from another one, and how individuals and groups may be able to resist such challenge to their privacy. And all of this will be in a continuous authentication scenarios. I want to explain that I'm going to do my PhD in the University of Kent, but I will have two secondments, like all of us. The first one is going to be in Universidad Autónoma de Madrid, and the second one in Colside. I consider my position very relevant due to the human-computer interaction that we have nowadays. A large percentage of the population has a smartphone which they interact every day for daily life and also for work. Day by day, the advantage in biometric recognition with this device increase the person. Okay, now I'm going to talk a little bit about the issues that I found and I wanted to solve in my PhD. The first question that I have is, it is possible to identify a user from the smartphone background sensors? To answer this question, we will first look at the three scenarios in which a user can interact with the smartphone. The first one is an active interaction. That is when the user is in interaction with the phone, like answering a call, swiping up, writing, etc. The second scenario is The second scenario is a passive interaction. That is when the user is carrying the phone but is not interacting with them. For example, that is when the user is running and carrying the phone, or just walking and carrying the backpack, etc. And the third one is when the user have no interaction with the phone. Like, for example, now that the phone is on the table and we are just using the computer or that kind of things. Another issue that I found is, can sensitive information be extracted from the background sensor of the smartphone? Identifying some trait of the person that you can set, for example, advertising or something like that. Some of the sensitive information that I found is gender. For example, if you know the gender of the person, you can send personalized clothing page. The age, if you know if it is a child who is carrying the phone, you can use it in a bad way and send in subscriptions, or maybe you can just protect the phone and block certain functions. Another one is health. Like, for example, we can determine if a person has some Parkinson's disease or ethnicity. And the third issue that I found is, can the user be identifying while protecting this sensitive information? So the point of my PhD is going to be like find a user authentication, but at the same time protect this kind of sensitive information that I was talking about. Okay, so for that I did an early review, and I was studying a little bit about the sensors that we have in the smartphones, which kind of user authentication can we have, which kind of sensitive information we found, some privacy protection methods, and also I'm going to explain a little bit about the dataset to be explored.
Paula, you're frozen. Oh, you're back.
Okay. Are you listening to me?
Yeah.
We hear you now. And
okay, sorry. So the specific scenario is when the user is interacting with the phone, and we need to interact in a certain way with the device to authenticate himself or herself. For example, using the PIN, facial recognition, etc. And in implicit scenario, it is not necessary to, for the user to identify himself or herself in a precise way. So for the implicit scenario, we have two types. The active interaction, like I said before, when you are writing, for example, or the passive interaction, that it is when you are just carrying the phone. Okay, about the sensitive information, I divide in three groups that I think that are the main groups. First of all, demographics, such as gender, age, weight, height, etc. Another group that we can find is health parameters and body features, for example, predicting the body mass index, stress detection, Parkinson's disease, etc. And another big group that I found is mood and emotion, like you can determine a person's state of mind or whether they are happy, sad, or neutral. So here I resume the two databases that I found that can be useful for my PhD. I choose these two because the first one, UMIDV, use active interaction. That means like the user is interacting with the phone doing some specific tasks. And the other one that it is motion sense is in a passive interaction. That is the user is just covering the phone with them. As we can see, both of them, they have some context data that can I use like sensitive data, such as age and gender. And I think that with these two databases, we can summarize all of the kinds of the user is using the phone. So I'm going to explain a little bit the possible first step in my PhD. First of all, analyze the user authentication performance. So how we can recognize a user with the background sensors. The second one is going to be study accelerometer and gyroscope sensors performance for sensitive data, because the two datasets that I explained before, both of them has these two sensors. The point is like the data extracted for these two sensors and how can be more accurate. And the third one is apply some techniques that allow us a trade-off between utility and privacy. So the point of my PhD is going to be at first try to compare a method that we can find a high utility with user recognition, but also can to try to protect the privacy data that in our case is the sensitive data. And that's all.